solving rational equations with extraneous solutions. You will probably want to have your guided notes in front of you. Okay, remember a rational expression is a fraction with polynomials for the numerator and the denominator. For example, let's look at these three: 1 over x, 2 over x plus 3, and x squared minus 3 over x plus 1. Okay, if x is replaced by a number making the denominator of a rational expression 0, the value of the rational expression is undefined. We're going to evaluate these for x that equals to negative 3, 0, and 1. So we're going to set up this table so you can see that here is our values of x, and then here's the three functions, and we're going to see what happens. All right, our first one is negative 3. When we plug it into the first one, it's negative 1 over 3. If I plug negative 3 into the second equation, please notice how this is going to, the denominator turns to 0, thus leaving it undefined. If I place the negative 3 in the third equation, please remember that your negative 3 squared is going to turn into a 9, and 9 minus 9 is 0, and so that's why it's 0. Okay, the next one is 0 for our x, so that means the first equation will be undefined. The second equation is 2/3, and the third equation is going to be negative 9 over negative 1 for 9. And then when we plug 1 in for our x's, we'll have 1, 1/2, and then the last one, the third one, will be undefined because in the denominator you will have 1 minus 1 for 0. Okay, so a rational equation is an equation between rational functions. And remember, to solve these, you're finding the LCM or the LCD of the denominators. You clear the denominators by multiplying both sides of the equation by the LCM. And then you solve the resulting polynomial equation. And remember to always check your solutions. All right, let's take a look at this. Notice with this one that our denominators are the same. And with their being the same, that means the LCM is the same, which means we can actually get rid of them and just say 1 is equal to x plus 1. Solve for x, and your x is 0. If you plug that 0 back in, you'll notice that nothing is going to be undefined, and that you have a negative 1/3 is equal to negative 1/3, and so this is true. Let's take a look at our second one. This time the denominators are not the same, and so our LCM is x minus 1. We are going to multiply by the LCM. Notice that we're going to do a lot of cancellations here. So our x's are going to cancel. The x minus 1s are going to cancel. And we wind up with this equation here. So now we just need to simplify. And what's our x going to equal to? That's right. It's going to equal a negative 1. Okay. Remember, after clearing the denominators, the solution of the polynomial equation may make a denominator of the rational equation 0. In that case, the value is not a solution of the rational equation. Okay, so it's always important to check your solutions. Let's take a look at this. Okay, we have an x squared minus 1. Well, how do you factor x squared minus 1? That's right, it's going to be x minus 1, x plus 1. Now notice the other side of the equation, the right side, has an x plus 1. So that means our LCM is x minus 1, x plus 1. Okay, multiply both sides by that. Cancel out what you don't need. So here, everything's going to cancel out. But on this side, only the x plus 1 will cancel. All right, then we get 3x plus 1 is equal to x minus 1. What is our x going to equal? That's right. Our x is going to equal to negative 1. Now notice, if we plug the negative 1 in here on this side, we're going to wind up with a 0. And so thus, this solution does not work. All right, let's take a look at x over x minus 3 is equal to negative 6 over x squared minus 8x plus 15. How do we factor the quadratic? That's right. The quadratic is going to factor into x minus 3 and x minus 5. So that is the LCM. Okay, here's the original equation. We're going to multiply both sides by the LCM. Notice what cancels out. And notice that we're going to wind up with an x squared minus 5x. We're going to move the 6 to the other side. And what's going to be our factors here? That's right, we're going to have an x minus 2 and an x minus 3. Set these equal to 0 to find our zeros. And notice that we have x equals 2, and if you look at your equation, you'll go, oh, we're okay with the 2. But when we look to check the 3, it winds up making the denominator 0. And that is all we have. Thank you for participating. The end.